Assalamualaikum warahmatullahi wabarakatuh. We are from Group 3. My name is Aiman Nuaim bin Abdul Halim. My entry number is 1202013.
My name is Umar bin Abdul Aziz. My matric number 1202002.
My name is Muhammad Bikri bin Muhammad Arshad. My matric number 1203141.
My name is Samidul Lukman bin Sabiza. My matric number is 1203138.
My name Muhammad Nofal bin Lamsadi. 1203142.
Al-Battani, or also known as Al-Battani, is one of the Islamic scholars of astronomy and mathematics. His real name is Abu Abdullah Muhammad ibn Jabir ibn Sinan al-Raqi al-Harani as-Sabi al-Battani. He was born in 858 CE in Haran, Bilad Asham, and died in 929 CE in Qasr al-Jiz near Samarra. Next, he was also a great scholar in Islamic Golden Age until he influenced the famous geographer Ptolemy, and he was influenced by Abu al-Wafa al-Biruni and Copernicus. His great, remarkable contribution to society is producing Kitabul Zij. Mathematics, astronomy, and astrology are his main interests, and his notable ideas is trigonometrical relationships.
Abdullah Muhammad ibn Jabir Al-Battani was born around 858 century in Haran. Battani was first educated by his father Jabir ibn San'an Al-Battani, who also a well-known scientist. He then moved to Araqah, situated on the bank of Euphrates, where he received an advanced education and later on flourished as a scholar. At the beginning of 9th century, he immigrated to Samarra, where he worked till the end of his life. His family had been member of the Sabian sector, a religious sector of stars worshipper from Haran. Being worshipper of stars mean that the Sabians had a strong motivation for the study of astronomy. Al-Battani, unlike Sabit and other mathematicians from his hometown, was not a believer in the Sabian religions. His name Abu Abdullah Muhammad indicated that he was certainly a Muslim. Al-Battani made remarkably accurate astronomical observation at Etihad and Araqah in Syria. The town of Araqah, where most of Al-Battani's observations were made, became prosperous when Caliph Harun al-Rashid built several palaces there. The Faris, who wrote a 10th century survey of Muslim culture, described Al-Battani as one of the most famous observers and the leader in geometry, theoretically and practically astronomy and astrology. He composed work on astronomy with tables containing his own observations of the sun and moon, and more accurate description of the motions than that given in Ptolemy's Almagest.
Rather than using the geometrical method, other the scientists had done, Al-Battani used the trigonometric method, which were an important advancement. Al-Battani showed that the farthest distance of the sun from the earth varies, and as a result, annular eclipses of the sun are possible as well as total eclipse. Al-Battani is important in the development of science for a number of reasons, but one of these must be the largest influence in his work had on scientists such as Tycho Brahe, Kepler, Galileo Galilei, Copernicus. All historians agree that Al-Battani passed away in 317 Hijrah near the city of Mosul in Iraq. He was regarded as one of the most famous Arab astronomers. He dedicated all his life until his death to the observation of the planet and the stars.
In mathematics, he was the first to replace the use of Greek chords with sign. The father of trigonometry, Al-Battani, was so named because he had introduced its use. He also managed to put trigonometry at a high level and was the first to produce a table of cotangents. In heyday of Islam, its civilization and center of knowledge became a reference for scholars who came from the east and west. At that time, the west was still in the dark ages. The knowledge of science, mathematics, philosophy, medicine, and so on is still not yet widespread compared to the Islamic world, which has succeeded in producing a number of scientists who are quite well known in their respective fields. One of them is Al-Battani, or better known in the West as Al-Battanius. His greatest contribution to the world of science and mathematics was in the field of astronomy, where Al-Battani had spent most of his life building a celestial study center in Rakia. He has proposed a method of measuring stars in the universe using curved lines. Before that, Greek scientists had introduced the measurement of stars using ropes, but Al-Battani's measurement was found to be more accurate and practical because it was based on the tangent and cotangent theories that he discovered. However, the West has never given credit to Al-Battani for the discovery of his theory. Instead, they extracted and stole Al-Battani's theory and modified and changed it to the Greek term sin, which is derived from the root word, namely sinus. This calculation that used by Al-Battani is still used until this day and became the basic for the creation of the clock, which is used in our daily lives. Therefore, the theory put forward by him turned out to be ahead of his time and was a considerable discovery, as well as changing the course of human history and mathematical knowledge.
Next is the contribution in astronomy. Al-Battani stated the Earth orbits the solar center in 365 days, 5 hours, 46 minutes, and 24 seconds. This calculation is almost accurate with the modern science calculation of solar year, which have 365 days, 5 hours, 49 minutes, and 12 seconds. Al-Battani also conclude how an annual solar eclipse occurs. By calculating the length of shadows and objects using trigonometry equation, he found that the attitude of the sun changed through the year due to the change of the distance of the sun and earth through the year. He concluded that when the sun was at its furthest distance from the earth, then an annual eclipse would occur. In popular culture, the ship in Star Trek is named after Al-Battani, known as USS Al-Battani. Some of popular manuscripts of Al-Battani is Al-Majesty and Zaj Al-Battani.